Hey everyone, today I'm going to be showing you the butterfly effect using lasers and cylindrical mirrors. And I'd like to thank Omaze for sponsoring this video. I'll tell you a little bit more about them later on. The butterfly effect is an idea in chaos theory that states that when you have a small change in initial conditions, it will have a giant effect later on. For example, you can see this video in starting a double pendulum. It looks like they all start at exactly the same height. And for a while, they stay together. But then after a while, you can see that they're wildly different. They're not synchronized at all. So they've all done crazy different things, but it looked like they had the very same initial conditions. Now the reason they're acting differently is not because some weird physics are happening, but these are deterministic equations, but the initial conditions were just slightly different, enough to result in a huge effect later on. The butterfly effect can be seen in a lot of different experiments. For example, watch the simulation created by Niels Berglund. In this simulation, you have the input of the laser here, and then we're changing the angle of it slightly. You can see that at the 9th decimal place, the angle is changing very slightly. But this tiny change in angle results in a huge change in where the laser ends up in its output. So this is a great example of the butterfly effect. Look at that seemingly insignificant change in angle completely flip the direction in which the laser exits the I made this round white, so I'll put it in here, then close this up. We'll have a round border where we can see the reflection of the laser. Now before we continue with our experiment, I'd like to thank Omaze. Now let's get back to our experiment. Okay, so let's turn on our laser here. So you can already see it's spread out a little bit. So I'm going to slightly change the angle of the laser now. Let's see what happens. See if we can figure out what's going on here. So this is not the same effect we saw in the simulation. In fact, what we're seeing is almost like every place that the laser could go, it's going. It's going in a complete 360-degree angle around the entire setup. Even when I'm not changing the angle, it's shining all around the complete setup. The reason this is happening is because in the simulation, our laser beam is a single point, meaning that it doesn't have a width at all. So you can trace the ray of it exactly where the one single point would end up. Imagine if it were a single photon of light. But because in real life the beam has some width to it, that means that the initial starting point of the beam isn't in the same location. And you saw how sensitive it was to the initial starting point, so you can see how because we have billions of different starting points across the width of the laser, it's as if we're running all these simulations at one time. And so just that small tiny bit of width, because of the butterfly effect, gets spread around in all 360 degrees. So this is pretty amazing here. You can see there's no clear path through. If I shine the laser, you can see that it ends up on my hand back here. So all the reflections are getting linearized out, and so it's able to go through. It's essentially able to pass through it undisturbed. So you can see how wide the beam gets. Then when you have that wide beam hit another cylindrical mirror right next to it, then that widens it even more, so it makes a semicircle. So each time the beam hits a cylindrical mirror, because it's not a point source of light exactly, it gets spread out. And eventually it can spread out into a full 360 degrees if we have enough rows of cylindrical mirrors. So in the end, it actually did work as in the simulation, but we weren't able to see it clearly because our beam is a real beam that has some width to it. Hey everyone, thanks for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe if you haven't subscribed yet, and also hit the bell so you can be notified when I release my latest video. And check out Action Lab Shorts. It's where I do videos similar to this channel, but I do them in a much shorter amount of time, less than a minute long. And thanks for watching, and I'll see you next time.